Hello, welcome to Honors Function. In this lecture, we're going to be reviewing the absolute value of a number. Let's first go over the definition of the absolute value of a number. So suppose that a is a real number. What do I call the absolute value of a? So it is either a if a is positive, or it is the opposite of a if a is negative or equal to 0. Okay, it doesn't really matter where you put the equality. I could have put it on this one, I put it there, it doesn't matter. Now be careful, I said here the opposite of a. I will often read that as negative a, but that doesn't mean that the absolute value of a is negative. Okay, if a is negative, then the opposite of a is of course positive, and that's what would we call the absolute value of a if a is negative. All right, so the absolute value is always positive. This is a property of the absolute value, it's always positive. This is the algebraic definition of an absolute value. The absolute value has also a geometric flavor interpretation. So here is the real line. I didn't talk about that in the previous video, although it's in my notes. A real line is a line. A line is a set of points, okay? So for example, here I will have the point A, here I will have the point B. So it's a set of points, that's a line. It's an undefined term in geometry. To every point we associate a real number. That's what we call the real line, the number line. To this point A we associate the number that I will often denote by x sub A and b x sub b, okay? And these are real number. There is a one-to-one association. This is called a coordinate system. This association is called a coordinate system. There is a particular point, often denoted by O, whose coordinate is 0, and this is called the origin of the coordinate system. Okay, so the absolute value, for example, of the real number xb represents the distance between 0 and the point b. That's a distance. I don't know if you've seen that in geometry. It's how we write a distance, and these of course are points. Okay, the distance between 0 and b is represented by the absolute value of xb. So right here, this distance right here, this distance right here is the absolute value of xb. This distance right here is the absolute value of xa. So the absolute value is a distance. I will often abuse the language. Let me define what an abuse of language is. Abuse of language. It's actually very specific in math. It's saying something that is not quite accurate, but it's much shorter than being precise. For example, I will say right here, I will say the distance between 0 and xb. Well, the distance between 0 and xb is not accurate, okay? Because 0 and xb are two real numbers. And we don't say the distance between real number because the distance is for something geometrical. It's a distance between 2 points, okay? It's not the distance between two numbers. We define the distance between 2 points. So when I say the distance between 0 and xb, I'm abusing the language, but we all understand what it means. It means the distance between the points of coordinate 0 and the point of coordinate b, xb. But that's just too long, so we say the distance between 0 and xb. Okay, well, that was a long explanation. Let's practice right now the first example. So without using the calculator, in this example 1, you have to remove the absolute value. Well, I know what to do, right? If root 2 minus 3/2 is positive, I'm following the definition, then the absolute value of root 2 minus 3/2 is equal to root 2 minus 3/2. If root 2 minus 3/2 is negative, then the absolute value of root 2 minus 3/2 would be the opposite of root 2 minus 3/2, which is just 3/2 minus root 2. Okay, the opposite of a minus b is the opposite of a plus b, which I can usually write, and I will write it like that all the time, b minus a. Okay, all right, so question: Is root 2 minus 3/2 positive or negative? Which one is true here? Now you cannot use a calculator, right? Let's suppose I don't know that root 2 is 1.41 blah blah blah. I'm not sure. So instead of comparing, so look, I don't know where root 2 and 3/2 are on this line. So what I'm going to do to root 2 and 3/2, I'm going to square them. Where's root 2 square? It's 2. Where's 3/2 square? Well, 3/2 square is 9/2. And 9/2 is above 2. Why? Because 9/2 is the same as 2 and... Sorry, I meant 9/4 right here. Yeah, it's 9/4, sorry about that. And 9/4 is 2 and 1/4, right? So it's 2.25. 2.25. Therefore, 9/4 is above 2. And if a squared is above b, and we know that everything is positive right here, if a and b are both positive, and if a squared is above b squared, that means that a is above b. Okay, so it's not true if a and b are not both positive, but if they're both positive, a squared above b squared means a above b. So here 3/2 squared is above root 2 squared, so that means that 3/2 is above root 2. If 3/2 is above root 2, then, sorry, right here, root 2, so that means that root 2 minus 3/2 is negative, right? And so the absolute value of root 2 minus 3/2 is equal to 3/2 minus root 2. Now you turn with number 2. Please do not use a calculator. Now that we have defined the absolute value of a number, let's define the distance between two numbers. Again, I'm abusing the language right here. Suppose here you have the point A of coordinate xa and the point B of coordinate xb. The distance between A and B will be defined as the absolute value of xa minus xb. Okay, xa minus xb. And it doesn't matter the order right here. We have a property of the absolute value. I wrote them at the end. The absolute value of A is going to be the same thing as the absolute value of the opposite of A. Therefore, I can switch the order inside. It doesn't matter. It's also the absolute value of xb minus xa. Okay, so this is the distance between 2 points, or if I abuse a language, I can say the distance between two real numbers. Okay, let's go over the second series of examples. In this example, I have to use interval notation to describe the set of points with coordinate x, the set of x's, that are no more than 2 units away from 5. So let's do a quick drawing, and it's going to be very, very simple. So I'm looking for the x's that are no more than 2 units away from 5. So suppose 5 is right here. Where can I go around 5? Well, I can go 2 units up, so I can go here, and I can go 2 units down. I can go also here, no more than 2 units away from 5. So how do I specify that? If I were to use absolute value, I would say that the distance between 5 and x cannot be more than 2. So here we go. That's how I would write it with an absolute value. But it asks me to use interval notation. So with interval notation, what's a number right here? 7. What's a number right here? 3. So with interval notation, this is just a set 3, 7. That's it. In this set, I'm no more than 2 units away from 5. Okay? Let's go over another example. I will do number 5. Do the next one, number 4, please. I'll do number 5. Now, in this set, I have to do the opposite. Describe the set -11, 3 as the set of x's that are no more than, or at least at, you have to decide which one. Is it no more than or at least at a given distance, so you must find the distance from a given point, and you must find that point. All right, this is a little bit tortuous the way I phrase that. I'm not sure there's a simpler way to describe it. There are a lot of choices right here. So anyway, let me show you what I meant. Here's the set -11 and -3. All right. Now, what is the center point of that set? What is the middle of that set? Negative 11 and negative 3, negative 14 divided by 2, negative 7. Negative 7 is the middle of the set right here. How do you go from negative 7 to negative 3? You just add 4. How do you go from negative 7 to negative 11? You subtract 4. All right? So, how do you describe this set? This is the set of x's, of points with coordinate x's, that are, so in this case it's no more, right? Because it's all in between right here. That are no more, so it's not at least that, no more than, how many units? 4 units away. 4 units away from which number? From negative 7. That's it. Okay? And we could also write that using an absolute value notation, an absolute value inequality. It's coming at the end of this lesson. So it is negative 7 minus x, the distance between negative 7 and x, negative 7 minus x, has to be smaller than or equal to 4. Okay? Alright, let's finish with a series of inequalities now. So to finish, I want to solve two types of inequalities. We've seen in the first video how to remove the absolute value around an equation. If the absolute value of x is equal to a, this is logically equivalent to, that symbol means is logically equivalent to, or if and only if, IFF, if and only if, x is equal to a, or x is equal to the opposite of a. So this is a way to write two equations. Now, I would like to solve this inequality right here, and I would like to solve this inequality right there. Okay? So this is not difficult. Let's look at it geometrically. What am I looking for here? I'm looking for the real number x's that are within a units from 0, right? This is the same as the absolute value of x minus 0. So the distance between x and 0, so suppose 0 is right here, the distance between x and 0 has to be smaller than a. So I'm going a up and I'm going a down, and that's what I'm allowed to do right here, right? So this is just, I can be right here. X can be anywhere there. What do I find if I move a up from 0? I find a. And if I move a down, I find the opposite of a. So this inequality right here, okay, so x smaller than or equal to a is the same thing as x between negative a and a. Okay? This is a double inequality. Remember, I think you must have seen that before. A double inequality stands for a conjunction. It means x above negative a and x smaller than a. It stands for a conjunction. Okay? Alright, before we apply this, let's look at the last one now. So in this one, what do we want? I'm looking for the point of coordinate, sorry, that's 0, the point of coordinate x that are at least a units away from 0. So I want to be, this time, I want to be a units away from 0. So again, I'm moving a unit up, and I'm moving a units down right here. But this time, I have to be at least a units away from 0. So right here, the set that I want is this one right here, and, or I should say, or this one right here, right? So this inequality right here is the same as x, oh, sorry, we still find the two same point right here, negative a and a, x above a, all right, so it's like if we're just removing the absolute value, but we have to be careful, there's another one, or x smaller than or equal to the opposite of a, all right? So guys, you need to remember this formula, you will see them again in some assessment. Let's finish with some examples. Alright, so I'm going to do 7 and 9, and you're going to do 8 and 10, okay? So what do we have to do right here? Well, first, I need to clean up everything around the absolute value. So let's subtract 6, so negative 3 times, this is the time right here, right? 1 minus 2x, absolute value, is above negative 6, and then I'll divide by negative 3. Be careful, when you divide by a negative quantity, you have to flip the inequality, right? So negative 3 by negative 6, or rather negative 6 by negative 3 is 2. Okay, and now I can apply the formula we just went over. So this is a less than, so I'm taking what's in the middle, 1 minus 2x, and I'm saying that it has to be between negative 2 and 2. And then I solve for x, this double inequality, subtract 1 from everywhere, right here, 2 minus 1 is 1, and then divide by negative 2 everywhere, right? So be careful, if you divide by negative 2, that becomes a 3/2, and you flip it right here, right? X, and then negative 1/2, okay? Use interval notation to express your solution. So writing this inequality or writing this interval, negative 1/2 to 3/2, is exactly the same thing, all right? So you can write this inequality or this interval, you are expressing the same sets of numbers. Number 9. All right, so we'll have to do the same thing, clean up everything around the absolute value. So the opposite of the absolute value of 5 minus negative 2 is I'm adding 3, smaller than or equal to negative 3, and then I'm multiplying by negative 1. So 5 minus 2x greater than 3. So absolute value of 5 minus 2x greater than 3, now I'm using the other formula. So this is a disjunction. It means that 5 minus 2x is above 3, or 5 minus 2x is below negative 3. So here I'm going to do that in one step. I'm subtracting 5. 3 minus 5 is negative 2, and I'm dividing by negative 2, so that means x smaller than 1. Or negative 3 minus 5 is negative 8, divided by negative 2 is 4, x above or equal to 4. How do you write that using an interval notation? So this is negative infinity 1, sorry, there's a bracket here, right? It's included, or, so it's a union, 4 infinity. And that's how you solve this absolute value inequality. In this example, we have another inequality with two absolute value. Let me show you how to solve this type of inequality. It is not difficult. You have to be careful and apply the formula. Which formula? The formula that describes how to remove an inequality that is above or equal to a positive value. I'm talking about this one. If the absolute value of A is above or equal to B, this is logically equivalent to, if and only if, A is above or equal to B, or A is smaller than or equal to negative B. In this case, A is the entire thing inside, okay? All right, so let's remove first the absolute value that is on the outside. So A above or equal to B, that means 1 minus absolute value of 1 minus x is above or equal to 1, or A smaller than or equal to the opposite of B, 1 minus the absolute value of 1 minus x is smaller than or equal to negative 1. Then we clean up what's around the absolute value and we keep on solving, okay? So this leads to that goes there and this goes right here. This leads to the absolute value of 1 minus x is smaller than 1 minus 1, 0, or same thing there, this here, or the absolute value of 1 minus x is above or equal to 2. All right, now we have to remove this absolute value. But when you look at the first one right here, what do you see? You see an absolute value that is negative or equal to 0. Well, don't forget, this is a disjunction. There's an or, right? An absolute value can never be negative. Can it be equal to 0? Yes. So basically, this only requires to have absolute value of 1 minus x equals 0, because the other one is impossible, and this is just the set 1, right? That will happen if x is 1. Or, so that's going to be a union in the end. What do we have here? Well, we're removing the same kind of inequality. So 1 minus x above or equal to 2, or 1 minus x smaller than or equal to negative 2. So that means x smaller than negative 1 or x above or equal to 3, right? So what are the two sets here? We have negative infinity, negative 1 bracket, or 3 infinity. Okay, can I write that differently? I cannot, right? Because 1 is in between negative 1 and 3, right? So you have this set right here until negative 1. Then you have 3 and above. And in the middle, you have 1 right here. Not exactly in the middle, but you have to take this point into consideration. That is the only way to write the solution of this inequality. All right, please do the next one. It's similar. I will finish this lecture by reminding you of some of the property of the absolute value that you have seen before. They are all trivial. I'm not going to prove them. They are very, very simple. This is from the definition. This is also from the definition. This is from the fact that a square is always positive and so is an absolute value. So writing an absolute value of a square is redundant, okay? Because you know that the absolute value of a is equal to a when a is positive or equal to 0, right? And a square is always positive, so you don't need the absolute value around the square. The absolute value of a product is the product of the absolute values. The absolute value of a ratio is the ratio of the absolute value. We could prove these two, but they are pretty trivial. I will stop this video right here. Thank you for watching.